Marshall for 5 minutes.
Thank you very much, Chairman. Both Dr. Schwartz and Dr. Higgs mentioned 3D printers. Chairman Lamar Smith and I recently got to go to Wichita State University and see the largest 3D printer in the world, about a third the size of this room, and would love to invite you all to come see what they're doing there on their Innovation Center. I always believe it's opportunities to promote each other and work together. I was going to ask Dr. Schwartz and Dr. Higgs both what they see, what's next for 3D printers, specifically, what's going to be a game changer, what type of more viable mass do we need, what do you see next for 3D printers? Dr. Higgs, you want to go first?
Very good. Thank you for the question. Definitely, I mean, if you think about it, when you look at Star Trek, you don't see really big manufacturing labs. You just see something very small, and then they ask for the product to be developed. And so that's kind of where additive would have to head. So you would want essentially to be able to additively manufacture anything. Yep. And that means that you have to be able to work with multiple materials. Right now you see a beautiful 3D printer, but it only prints a limited amount of, say, materials that are there. So if it's the big one that you talked about, it's probably a metal printer, and if it is, it's a limited set of materials. But if you want to print something that's, say, biocompatible, then you may not be able to use steel or gold or something like that. And so you need to be able to change out the different materials. If you want them, since it's additive, you can build part by part. You want the mechanical properties to change as you want them to. Then that means you have to have a functionally graded material, which means that it may start one mechanical property at one end and be another at the other end. Right now, that can't be done. And so there's some important material science questions which have to be answered. But the point is that you want print anything as you want as it could occur. Additive can do that in principle, but the basic science questions have to be answered to unveil that to the society.
Okay. Dr. Schwartz, anything to add?
That's an excellent question. And to me, the key to successful deployment of additive manufacturing in this growing industry in the U.S. is all about understanding the materials properties. Researchers have been trying to understand details of steel, aluminum, titanium alloys for decades, if not centuries, and they still don't have full understanding. Now we want to make additively manufactured parts out of the same materials, but the process is so much different. The composition will change as you melt and remelt as you make the powders. Right now, I believe the key is getting a fuller fundamental understanding of, starting at the very beginning, developing the metal powders. Without the metal powders, none of the metal additive manufacturing happens. Those powders have to be pure, they have to be spherical, they have to flow nicely, they have to have the right surface conditions. And all of this is based, we need that basic research understanding to get there. No one has ever looked at laser melting of particles in great detail. This is a brand new field. Ames Laboratory is working with SLAC and Lawrence Livermore National Laboratory in using one of the national user facilities, Stanford Synchrotron Radiation Laboratory, in order to understand the early stage materials melting and resolidification and development of that most important internal structure that's going to control the properties. Yeah. It's a very exciting time.
It is. One of the exciting things I saw was the ability to take away from the product that it's printing and telling the machine or to maximize the to maximize it. So they were doing wing replicas and trying to have a stronger wing for airplanes, for jets, but yet lighter, and to see that technology come forward. So it is very exciting as a physician to see what they're doing in joints, to think that instead of having your choice of hip joints as small, medium, or large, you could actually make one that fits your joint is exciting. Last question for Dr. Higgs. I see that you won the NSF Career Award, so congratulations. Professors at Kansas State University, which is the champion of the Texas Football League this past year, having defeated
this gentleman's time is also expired.
Texas A&M, TCU, and Texas Tech. Anyway, professors at Kansas State University, Wichita State University, and University of Kansas have all won that recently. Tell us a little bit about that and how it's what you're doing with that foundation grant, please.
Very good. So I had an NSF Career Award. It's supposedly given to the nation's youngest best young researchers. And I do want to say that the research from that, which was actually to develop slurry technology, was about 5 years after that grant. It became an NSF SBIR company, Innovalgy, that I now have. And so it's making it back into the marketplace because of the basic science research that's now translated into a small company. Thank you.
The gentleman yields back. Ms. Susan Bonamici is